ORNL tests Viridi battery storage under live grid conditions. A battery energy storage system from Viridi has completed testing at Oak Ridge National Laboratory's Grid Research Innovation and Development Center, or GRID-C. The project examined how storage equipment and grid control technologies perform together under active electrical conditions. The Buffalo, New York-based manufacturer installed its RPS-150 system at GRID-C as part of research supporting a USC Department of Energy initiative focused on grid reliability and resilience. Rather than assessing storage capacity alone, the work explored how batteries, converters, and distributed energy resources can respond to coordinated control signals. That capability is becoming more relevant as utilities connect larger numbers of solar installations, electric vehicles, building systems, and other assets to distribution networks. ORNL moves battery storage testing onto a live grid. The project builds on ORNL research into a control platform designed to manage groups of grid-connected energy resources according to utility requirements. Researchers initially tested the control architecture indoors using simulated generation sources and battery storage equipment. Those controlled trials helped ORNL evaluate the core system, but simulations could not fully reproduce the charging patterns, converter behavior, and electrical interactions found on an operating grid. Viridi's RPS-150 was subsequently installed at GRID-C's power distribution field test site and connected to an ORNL converter system. This setup allowed researchers to assess the laboratory's alternating current and direct current architecture using physical equipment under more realistic operating conditions. The test also gave the research team an opportunity to identify integration issues that may not become visible until batteries, power converters, and grid management software are operating as one system. ORNL Electrical Systems Integration Program Manager Madhusudan Chinthavali described the work as a step toward closing the gap between simulated testing and real-world electrical performance. According to information released about the project, the battery integrated with ORNL's research management system, while Viridi's engineering team assisted with installation and testing. Why integration matters, more than capacity alone. Battery energy storage systems are taking on a broader role as utilities respond to increasing electricity demand, aging infrastructure, and more complex power flows. Storage can help balance generation and consumption, support voltage and frequency management, and provide backup capacity during disruptions. However, those benefits increasingly depend on whether multiple batteries and other distributed resources can be managed as a coordinated network rather than as standalone assets. For utilities and project developers, this changes how battery systems are evaluated. Capacity and discharge duration remain important, but buyers must also consider communication protocols, control system compatibility, and performance under changing grid conditions. The ORNL project also provided a technical setting in which Viridi could demonstrate its battery design. The company markets its lithium-ion systems with an anti-propagation configuration intended to limit the spread of a failure from one cell to other parts of the battery. The GRID-C work should not be treated as an independent certification of all safety claims. Its primary focus was system integration, grid controls, and electrical performance, rather than a comprehensive validation of the product's fire safety characteristics. Viridi CEO John M. Williams presented the collaboration as evidence that the company's technology can support advanced grid research. More broadly, participation in national laboratory testing may help manufacturers address the technical requirements that utilities and infrastructure operators consider when selecting storage systems. At the time the project was announced, testing had concluded, and ORNL planned to present its findings in the following months. Viridi and the laboratory also indicated that they intended to explore additional research opportunities. The project reflects a wider shift in the battery market. Storage systems are no longer judged only by how much electricity they can hold. Their ability to communicate with grid controls, respond to changing conditions, and operate alongside other energy resources is becoming just as important.